So today we're going to look at the first part of law of sines. Okay, basically, the law of sines is used to find out how big angles are in a triangle, how big sides are, whenever you don't have a right triangle. Okay, so we've done this before with Socotoa, right? Opposite of a hypotenuse, adjacent over hypotenuse. Okay, well that works great as long as you have a hypotenuse. If you don't have a 90-degree angle, you don't have a hypotenuse. Okay, so there's really two kinds of oblique triangles we can have. The actual shape of the triangle has no effect on how we use this law, but if you're just thinking, well, what does he mean by oblique? Think of like an equilateral triangle. Okay? In general, that's an acute triangle. All the angles are smaller than 90. Or you could have a triangle that's obtuse, where one angle is bigger than 90. Those are the two types of non-right triangles you can have. Why can't you have an obtuse triangle with two of the angles bigger than 180? Or bigger than 90?
Over 180.
Yeah, would be over 180. Okay, so at most,
It would be a quadrilateral.
yeah, it would be a quadrilateral, okay, or some other shape. So at most, you can only have one angle bigger than 90. Okay, and here's our diagram we're going to use for solving oblique triangles. Again, you can draw it acute, you can draw it obtuse, it doesn't really matter. What does matter is the relationship between the name of the side and the angle. Okay, you want to make sure we're putting A across from alpha, okay, B across from beta, and C across from gamma. All right, so now gamma, we never had to use that before. Okay, we didn't use it because we always had a right angle. We just called it the right angle. Now it's not a right angle. Okay, so we call it gamma. Okay, G-A-M-M-A. It's gamma. Right? As you go through it, if you look in the book, okay, you might see that they use different letters sometimes. Some books use like a capital letters for the angles and lowercase letters for the sides. Why do you think I'm not as much of a fan of labeling things that way? Capital letters for angles and lowercase for sides, especially with a certain letter here.
Because for the life C, yeah, it's not necessarily, it's the same exact shape, but it just depends on the size that you put it.
Yeah. So like if you said C equals on your paper, it'd be hard for me to tell, is that a capital C or a small c? This is very clear. Right? Also, if you ask me like what's A, I know you're talking about a side. If we use capitals and lowercases and you said what's A, yeah, I'd have to say, well, do you mean capital A or lowercase a? Which one are you talking about? So if you ever see that in a book, again, whether it's our book or another book, if you want to change capital letters to the Greek letters, I would recommend doing it that way. Okay? Or if you ever have a test and they use capital letters on it, you can cross them out, put the Greek letters. Okay? All right, there's really two laws that we're going to study. We're not going to do the other law until next academic week. But the two laws are law of sines and law of cosines. There's no law of tangents that we're going to use. I think there is a law, but we don't need it. Law of sines is used to solve a couple different types of triangles. It's used to solve an angle-side angle, a side angle, and a side-side angle. Angle-side angle and side angle are the two ways they can give you two angles and a side. And I'll draw a picture of each one. Right, so I'll put this back up, but let me show you angle-side angle. That's where they give you two angles and they give you a side, but the side they give you connects the two angles. So we could do 10, 115, 6. That's an angle-side angle triangle. Okay, any question on that? Okay, now the difference between angle, side angle, and side angle angle. This time, they're still giving me the same information, but the side they're giving me is not between the two angles. So let's say they give me 10, 105, and 20.
You already saw the third angle.
Yeah, with these types, you can get the third angle right away. That's very easy. Okay, so here's side, angle, angle. One way you could do it. Okay? As long as in this case, the side they give me does not connect the two angles. Okay. Any question on those two, what those two types are, like just classifying it? Okay, and the third type, we've got side, side angle. Now on the first one, I don't really care if you write ASA backwards because it's still ASA.
The word SSA backwards?
If you write SAA backwards, that's okay. You could call it AAS. I might do this sometimes. That's fine. The third one, I'd prefer it in this order. just to be polite, you know. So, okay. Side, side angle. This one's a little different because you can't do what Aiden said right away. You're going to be given two sides. You're going to be given an angle. But you can't do the... Yeah, you can't get the third angle right away.
The angle and the sides.
Okay, so here's two sides and an angle. Okay. So any questions on what makes this side side angle? This would be very different if it was side angle side. Okay, we cannot solve a side angle side problem with the law we're learning today. It doesn't work. Okay. There's one other combination here. Anybody think of the other combination of letters? Okay, side angle side, that's not today. That's a different law. And one more. Side, side, side. Okay. Side, side, side is a case, but it's not something that would work with law of sines. Okay, that's a law of cosines problem. All right. So these are the three cases we're going to look at. All right. So as I just said, to solve any of these three types, you use law of sines, and you use law of sines only for these three types. Yeah, I heard somebody mention maybe Pythagorean theorem.
That does not work.
Right. Unfortunately, because we don't have right triangles, we can't use Pythagorean theorem. Also, because we don't have a hypotenuse, we can't do opposite and adjacent. We can't do any of that stuff either. Yeah.
I was gonna say for like the side angle, can't we use like drop an angle bisector down, or would that not work?
Oh yeah. Yep. There's
Altitude, yeah.
there's different ways we can solve these problems, and if you think of geometry, we can do it. But what we're gonna do is come up with a formula for doing it, so we don't have to think about the geometry. Okay. So we're going to go through the proof of law of sines, okay, which is going to be kind of based on what Brian said. And I'm not going to go through the entire proof. I'm going to go through the first two parts, and from there you could see the third part it's the same thing, just repeated. But start with a triangle. Okay, let's label this side A. Label this angle alpha. Okay, let's label this side B and this side beta. I don't need to label the third side. I'm not going to use it. Okay, my first step is I'm going to draw in an altitude, okay, from the top vertex straight down. And that's, we could just call it the height of the triangle.
Want to solve the two separate?
All right, so now what we're going to do is try to solve for the height. Okay. First thing I'm going to do is just focus on the left triangle. Okay, I've got two right triangles, but let's start with the one on the left. Okay, what angle is labeled in that triangle? Beta. Okay, it's the only one we've given a name to. And I want to figure out a trig function that would involve the side that's opposite and the hypotenuse. Sine. Okay. What would sine of beta equal? H over A. And now I just want to get H by itself. So what would H equal?
Sine beta times A.
Yeah, or we could just write A sine beta. Okay, so there's a formula for finding the height using the left-hand triangle. Okay, now I'm going to do the same thing again, except we're going to use the right-hand triangle. Right? So what angle is labeled here? Alpha. And what trig function would involve the H and the B? Sine. And what would that equal? Sine of alpha equals
H over B.
opposite over hypotenuse. H over B. Okay, do the same thing again. Get H by itself.
B sine alpha.
H equals B sine alpha. So we have two different ways of calculating the same thing. H is equal to A sine beta. H is also equal to B sine alpha. There's one more fact I could write based on those two.
That they equal each other.
They equal each other. What's in the first box and the second box equals each other because they're both equal to H. Okay, so A sine beta equals B sine alpha. Okay, and now the last thing I'd like to do is try to get all the A's and alphas on the same side and the B's and betas on the same side. So what could I divide each side by to do that?
A and B.
Yeah, divide by AB. Okay, now normally I say be careful when you divide by a variable because it could be 0. Well, this is a triangle. It's impossible for the length of a side to be 0. So you don't have to worry about A or B being 0. So what would cancel on the left? What would cancel on the right?
B.
Okay, and that's basically the law of sines. Okay, the first two parts of it. Sine of beta over B equals sine of alpha over A. Usually we put it in different order. We say sine of alpha over A, then sine of beta over B. Oops. Yep. Okay, so that's the first two parts. Any guess what the third part is if it follows similar?
Game over C.
It's sine gamma over C. Now, we didn't prove the third part. Okay, to prove the third part, all you'd have to do is take the same triangle, draw in the altitude from a different vertex, okay, and use two other sides. Instead of A and B, use B and C, and you could prove the third part. But it would be this again. Okay, so this is your law of sines. Okay, we never use all three parts at once. You're either going to use the first two parts, the last two parts, or the first part and the last part. Okay, you can still use the fact that all the angles add up to 180. Okay, that's still true. You just can't do anything with Pythagorean theorem or opposite, adjacent, and hypotenuse. Okay, we're going to use this equation. Okay, any question on the law of sines? Okay, so as Brian said, it really just comes from separating a triangle into two right triangles. But now you're not going to have to do that in every problem. This formula builds that in for you. So when you use the law of sines, you're basically creating two right triangles and solving them. All right, so let's try to solve this triangle. Let's see. When we did this before, two things we did. One, we had kind of a structure to organize our answers. Okay, so we're going to set up that same structure we had before. ABC, alpha, beta, gamma. Okay, I'll fill in what I know. And I'll put boxes around everything I need to find. Okay, what do you think the next thing I should do is?
Find,
Yeah,
gamma.
make a triangle, okay? Because then you can at least visualize whether is it, a side, is it side, is it angle, side? Because depending on the type of problem, that's going to change whether you use law of sines or law of cosines. On the next test, you're going to have that choice, right? For this test, all we're going to do is get through law of sines. Okay, but it's still good to make our triangle. Okay, I'll put A here, okay, alpha there. I'll put B for the base, and I'll put 60 across from it. All right, and keep in mind, my diagrams are not going to be to scale, so I might have an obtuse angle and it might come out acute, it's not to scale. All right, so what can I find pretty quickly here? You don't even need the law of sines to find this.
Gamma.
Yeah, what is gamma?
100.
Yeah, it's 100 degrees. Now, when we solved right triangles, I said to you, don't use anything you find to find other things, because if you find something and you get it wrong and you use it, then that's wrong.
Pretty sure.
Well, with law of sines, you can't really do that. You have to sometimes use things you find to find other things. So it doesn't mean you'll maybe get the whole problem wrong. Like if you got gamma wrong, you could still get B right. But if you get gamma wrong, you're definitely going to get C wrong. Okay? So you do have to use things you find to find other things. All right, let's start with B. Okay, so we have to look at the law of sines and look at the row that has everything in it. That's definitely an important row. We're going to use that row to find B, and we're going to use it to find C. So what row has everything in it?
A.
Row A. Okay. We know A, and we know alpha. Okay, so we're going to fill into the law of sines for the first part. Right, sine of alpha over A. So sine 20 over 4. Now, what you put on the other side is going to dictate whether we find B or we find C. If we're going to find B, we're going to use this. Sine beta over B. Okay. If you wanted to find C, we would use the last part. Okay, we'll do that at the end. Okay, so let's put sine 60 over B. Okay, and what did we just set up? What do we call this thing?
It's B, not B. It's B.
Oh, thank you, B. Yes. Okay, what is that? Not a ratio, but it's a proportion. Now, how do we solve a proportion?
Cross multiply.
Yeah, just cross multiply. You're going to do 4 sine 60 equals B sine 20. And my last step, I have to get B by itself. Divide by sine 20. And divide by sine 20. Okay, we do need to type that in, and we'll just round to 3 decimals. Everything in this section is going to be degrees. Okay, so make sure you put it in degrees. Okay, we got 4 sine 60 divided by sine 20. Okay, so you should get about 10.128. Okay, for B. Right, now C should be even bigger. Okay, biggest angle, biggest side, smallest angle, across from smallest side. Right? But I know C can't be any bigger than 14.128. Anytime you add 2 sides together in a triangle, they have to be bigger than the third. So C is bigger than 10.128, but smaller than 14.128. Somewhere in there. Right, let's find C. Okay, what's going to be my proportion to find C? Yeah, reuse that first row. Okay. And I like the idea of that row. Even though we know row B now, don't use it. It's a decimal. Okay. Even if we got gamma right, you wouldn't want to use row B because then that's an approximate answer for B. Okay.
Also because B is not given to you, which A and alpha are given to you.
Yeah, use as much as given as you can. Okay. And what goes on the other side?
Sine 100.
Yep. Okay. And when you cross multiply, you're going to get 4 sine 100. And then you're going to have to divide by sine 20. And you don't have to show me the cross multiplying. You can just write that step. That's fine. All right, so if you can just hit second enter, you can just bring up the last answer. And that's what you got.
11.51.
11.518. And that fits with what I said. It should be bigger than 10, but it had to be smaller than 14, so things look reasonable. Okay, any questions on that one? Okay, we just got to do one of each type. Okay, which type was this? This was the
Side angle.
side angle angle. Or angle angle side. Yep. Okay, let's try this type. Which type is this one? Is ASA one of the 3 that I said you use law of sines for? Yeah. So we're going to use law of sines. Okay, we've already got our diagram, so don't worry about that. Now we have to look at the diagram and interpret what these things are. What's the 40?
Beta.
That's beta. What's the 45?
Alpha.
That's alpha. And what about the 4?
That's CC.
Okay, as you start to do more law of sines, you're kind of going to notice the key when you set up the table, if you have a row with everything in it, that's when you can use law of sines. Okay, if you didn't have a diagram, that's how you can tell. If you have a row or you can find something to make a row complete, you can use law of sines. If you had information and it didn't give you a complete row, like side, 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 you can't use law of sines. Okay? Or side, angle, side. Okay? You wouldn't have a row that's complete, and you'd have no way of finding it. Now, were we given a row that's complete?
No.
No. But can we find something? Yeah. We can find gamma,
95.
95.
No, it's right up.
Any question on that? Are we get 95? That is correct. All right, now that's important because in this problem, the key row for everything is row C. If you get gamma wrong, we're going to use it to find B, and we're going to use it to find A. So in this one, if gamma's wrong, they're all wrong. So everyone agrees that that's 95? Okay. Okay, what would be my proportion to find A?
Side 95 over 4.
Sine 95 over 4.
Sine 45 over
Sine 45 over A. Okay, so A would equal 4 sine 45 over sine 95. I'm going to leave finding the decimal for you. And what's my proportion for finding B?
It'd be sine 95 over 4.
Yep, we're gonna-
Sine 40 over
Just going to repeat that first part again.
sine 40 over
Sine of 40 over B. Okay, can anybody tell me what, you don't have to give me the decimal for B, but just tell me what times what over what?
4 sine 40 over sine 95.
Over sine 40 over sine 95. Okay, if anybody has the decimals, we can write them.
2.839.
We've got both of them.
29 for A.
And 2.581 is the second.
2.3,
89, or 839. 2.8.
2.839.
and
And then the other one's 2.581.
581. Okay, let's see if everything makes sense. Biggest angle with the biggest side, smallest angle with the smaller side. Okay, 40 and 45 are pretty close. So these sides should be very close, and they are. Okay, it's almost a right isosceles triangle. Almost, but not quite. Okay. Okay, any question on that type? All right. Last type. Okay, this one's a little different. Okay, because we have two sides and an angle. Okay, with this type, different things can happen. Okay, it could turn out to just be a normal problem, and we just go through the whole thing and we end up getting one solution for everything that's not given. Okay, we could also go through it and end up with two solutions. Okay, and this is going to directly connect with what we've been doing, and you'll see why. Or we could get no solution. Okay, side-side angle is the only time that can happen. You don't have to worry about this happening with anything else we've done today. You're not going to have to worry about this happening when we learn law of cosines. This is the only case, side-side angle. All right, so let's try a side-side angle. Okay, I'll use the problem I have up above. A is 3, B is 2, alpha is 40. What can't you do here that we could do right away in the last two?
Get all angles.
Yeah, you can't just add up two angles and get the third.
You can't get all sides.
Yeah, we can't use the Pythagorean theorem to get the sides. So this time, we are forced to find something first. Okay? Sometimes you've got a little flexibility, what you want to find and the order you do it in. Not in this problem. What do you have to find first? Have to find beta. You've got to use row A, because it has everything in it. And you can't use row C, because it's missing everything. If you tried to fill in row C in law of sines, you'd be missing the top, and you'd be missing the bottom. Okay? Got to work with 3 pieces of information, and the first 2 rows have 3 pieces, so we have to use them. All right, so somebody else, what kind of proportion can I set up here?
Sine 40 over 3.
Sine 40 over 3 equals sine beta. That's a little different than what we've had so far, but we've seen that before. Over 2. Still going to cross multiply. So 2 sine 40 equals,
3 sine beta.
it would be 3 sine beta, and if I want, put the 3 on that side. Okay. I think in this problem, it's actually simpler not even to cross multiply, just multiply each side by 2. Okay. Then you don't move the 3 to the other side and then just have to move it back. Right, so
Let's do inverse sine.
now we have to do inverse sine. Right. 2 sine 40 over 3. Okay, so let's type that in and see what we get. Inverse sine of 2 sine 40. Let's try it again. Inverse sine of 2 sine 40. Okay, make sure you close your parenthesis for the argument. Okay, that should be fine. And then close your parenthesis for, and you should get 25.374. Okay, now, if this was a no solution case, we would know right now. We would have gotten an error on the screen. So this is not a no solution. It's at least a 1 solution. Could be a 2. 25.374. What I usually do is I write the answer high in the box. If there's a second answer, I'll call it beta 2, and I'll put it right in the bottom. All right? So we were looking for where sine equaled, what kind of number is that, positive or negative? It's a positive. Okay, we just got the answer 25.374. Where would our other answer be? In quadrant 2. In fact, this is always going to be positive because you're always going to have a positive side. You're always going to have a positive side. And in these kind of triangles, your angles are always between what 2 numbers? Yeah, they're always between 0 and 180, not including them. Well, if you take the sine of anything between 0 and 180, it's always positive. Okay, so this fraction is always a positive. It's never negative. Never. So now we got one answer in quadrant 1. You guys told me the other answer is in quadrant 2. What do I do with my reference angle to get the second answer? Subtract it from 180. 180, what was our reference angle?
25.37, or 374, sorry.
That's the other answer if it works. Okay.
That's not.
Yeah, it definitely does.
154,626. I'm just going to write it off to the side.
Once before, you're already
40,
you're already done.
Right. To figure out if the second answer works, look at what they gave you. Look at what you want to try to use. They gave me a 40. Okay, I know that's correct. Can I fit a 154 and a 40? No. Because this angle came out too big this time, the second answer doesn't work, and we don't have to worry about a second answer for the rest of this problem. If there was a second answer for beta, how many answers do you think you'd have for gamma? 2. And then for C, 2. So when there's a second answer, it's not harder, it's just longer. We have to do each calculation twice. Okay? But now that we know there's not a second answer, we can get gamma. Okay? How do I get gamma?
Add 40, 25, 74, and then subtract it from 180.
Yeah, I've got 2 angles. Now I can add them up and subtract from 180. So 180 minus 40. So we get 114.626. And now that we have a piece of information in the last row, we can finally find what? C. Okay, now we can do C. All right, so which row am I going to use to find C? Besides, I'm definitely using row C. Use A. Don't use B. Okay, we've talked about why. That's an approximate answer, and if it's wrong, then everything else is wrong. Okay? Granted, if beta is wrong, we probably already got gamma wrong anyway, but still use what was given. Okay, so sine 40 over 3 equals what?
Sine 114.626
Over
C.
C. Okay, so we cross multiply. And if somebody has that decimal, that would be good. So 3 sine 114,626, and then you divide by sine 40. And that's your answer for C. Okay, I do know that it has to be less than 5. And it has to be bigger than 3. So it's between 3 and 5. Anyone have the decimal?
4.24.
4.243.
4243? Okay. Thank you. Okay, so you might have noticed in this problem, what trig function did we have to use that we didn't have to use in the other two? Inverse sine. Anytime that you need to solve for an angle, you're going to have to use inverse sine. If you're not solving for an angle, you don't need it. Okay? Okay, so this part you guys already know, but to check if there's a second answer, okay, we know we have to be in quadrant 2. So you do 180 minus your reference angle. Okay? It could be beta, it could be alpha, it depends on how the problem is set up. It could be gamma. Okay, but you do 180 minus the reference angle, and then take that answer and see if it's possible to fit that answer and the given angle in the same triangle. And by possible, I mean, does it add up to less than 180? Right, so in our problem, if there's another answer, it was 180 minus, I just rounded it, but minus the 25.374. Okay, when you do that, you get 154.626. But we were given a 40-degree angle to start, and that adds up to more than 180. Okay, so the other answer didn't work. Tomorrow, what we'll do, we'll look at the case where we can review this case, and then look at the case where the other answer does work, and then we can do the case where we get no solution. Sorry, not tomorrow. That'll be next time, next academic week. Right, so we'll pick up with law of sines next academic week, but I think this, even though we're splitting it, this is not an overly hard topic, so it's easy to pick this topic back up next time. All right, so the homework is all of that. Okay, page 435, 5 through 8, 10 and 16. And I want you to solve these two types. They don't give you these types in the homework. Okay, so try solving those two extra triangles.
Why do we have four different?
It's because it's 2 types of.
What's that?
Oh.
Okay, I'll go over this first thing tomorrow. Okay, we'll have our test. If you need extra help, I will be here after school today till about 3:30, 3:40.